What is the Laplace transform of a derivative? Well, let's see. You have f prime x, the first derivative of f of x. And you want to find the Laplace transform of that. Now, this will be equal to the integral from 0 to infinity of e to the negative sx f prime x dx. Of course, where s is a constant. Now, let's use the integration by parts method. You know that the integral of u dv is equal to uv minus the integral of v du, the formula for integration by parts, and it is derived from the product rule when differentiating. U and v are functions. Now, let us say u in this case, u is equal to e to the negative sx, and dv is of course equal to f prime x. Now, du, to differentiate u, will be negative s e to the negative sx. That would come from using differentiation by substitution. It is a chain rule, right? Going from dv to v, we have to integrate dv, and you get v, which is the integral of f prime x with respect to x is just f of x. All right, good. So, what we have here as the Laplace transform of f prime x is going to be u, which is e to the negative sx, v, which is f of x, minus the integral of v, which is f of x, du, which is negative s e to the negative sx. Now remember, you're going from 0 to infinity. So, for this first part, you're going from 0 to infinity. For the integral, you're going from 0 to infinity. All right. So, let's see what else happens here. You have this is equal to, now, e to the negative sx is 1 over e to the sx. So let's write it like that. 1 divided by e to the sx times f of x. But the f of x, we could just put it up here. Say f of x, and we're going from 0 to infinity minus. Now, let's fix this part up. We have a negative out here, and we have a negative, so minus negative. That will give us a plus, and we can bring the constant s outside the integral sign. So this is s, the integral from 0 to infinity of, let's write this part on the left, e to the negative sx, and the f of x on the right, f of x dx. Oh, I didn't put the dx up here. All right, so here now, let's substitute the values in this part. This is f of infinity over e to the s of x, which is infinity, minus substitute the 0 now, f of 0 over e to the s times 0 plus s integral from 0 to infinity of e to the negative sx f of x dx. Now what does this part give us? E to the infinity. That's an infinitely large number. Any value divided by that is 0. So it's 0 minus f of 0, whatever it is, over e to the 0, which is 1. Alright? So this is what we have on the left. Plus s times, hold on, the integral from 0 to infinity of e to the negative sx f of x. Looks familiar, doesn't it? Here, the Laplace of a function is integral from 0 to infinity of e to the negative xx f of x. Right? So this is the Laplace transform of f of x. Because remember, when you're finding the Laplace transform of f of x, it is the integral from 0 to infinity of e to the negative sx f of x. And this is also called f of s. Alright? Now, this here is s times the Laplace transform of f of x. You can see that. Now, here, this is equal to now. What we have is negative f of 0 plus s. But what you call the Laplace transform of f of x is also called f of s. Right? So this can be written as s f of s minus f of 0. Now, when you look up the transform, the Laplace transform of f prime x, this is what you will find. S f of s minus f of 0. So this is the Laplace transform of f prime x.